Drugs acting on autonomic nervous system is one of the most important topic in pharmacology. So, our entire body functions are under the control of two main systems. That is, one is nervous system and the endocrine system. It is involuntary control on our body. Where the nerves can reach, it will be controlled by the nervous system, and where the nerves cannot reach and blood can reach, it will be controlled by the endocrine system, that is the hormones. But we deals with the nervous system right now. So the nervous system, ANS nervous system, is divided into two divisions, that is central nervous system and peripheral nervous system. So the study in pharmacology will be also accordingly. Central nervous system will be a separate chapter, and we'll see the peripheral nervous system right now. It is divided into one is sensory nervous system and motor nervous system. The sensory nervous system gives informations about the external environment, and the motor nervous system will give informations to the various organs to respond accordingly. And the motor nervous system we can divide it into two, that is somatic nervous system and autonomic nervous system. The somatic nervous system is under voluntary control. We can control the muscle movements, we can produce muscle contractions, we can raise a book, we can walk, we can stand up. So that's all under voluntary decisions. It is done by the somatic nervous system. But autonomic nervous system, it is involuntary. And autonomic nervous system is divided into two, that is sympathetic nervous system and parasympathetic nervous system. So autonomic nervous system, as the name tells, it's autonomic, is involuntary. So it is being under the decisions of the neurotransmitters and the receptors associated with that according to the requirements of the body, and also with the responses from the external environment. So autonomic nervous system will control many of the functions in the body through the parasympathetic nervous system and the sympathetic nervous system, which are mutually opposing each other, in fact, so that it can regulate the body functions. If you see the autonomic nervous system, it will be having two set of neurons. One, it is first neuron which originate from the origin where it starts. Usually it is from the spinal cord, and the second set of neurons which forms synapse with the first set of neurons, and which will innervate the effector organ. So this is a simple diagrammatic representation of the neurons which are involved in autonomic nervous system. Coming to details, if the neurons are originating from craniosacral region, we call craniosacral origin. That is, if the neurons are first set of neurons, as I mentioned before, you can see here again the neurons which is originating. If it is originating from the nuclei of the cranial nerves or from the sacral vertebrae 2, 3 and 4, we call it as parasympathetic neurons. While if the neurons are originating from the thoracolumbar region, that is from the thoracic area of the spinal cord or from the lumbar 1 and 2, we call such neurons sympathetic neuron. This is an anatomical classification or a physiological classification as per the origin of the neurons in the autonomic nervous system. So they are known as parasympathetic if they are originating from the craniosacral region, and they could be called as sympathetic neurons if they are originating from thoracolumbar area. Have a look. If the neuron is originating from the craniosacral region, we call parasympathetic neuron, and the first set of neurons will be forming a synapse with the second set of neurons. You can see the anatomical difference. The first neuron is more lengthier, second neuron is shorter compared to the first neuron, and the second set of neuron will be forming a synapse with the effector organ. And the synapse between the first and second set of neuron we call it as autonomic ganglia. And the synapse between the second set of neuron and the effector organ we call it as effector junction. The first neuron we will call as preganglionic neuron. That's the neuron which is originating from the origin, that is craniosacral origin, or anywhere, thoracolumbar, whatever it is, the neuron which initially originate we call as preganglionic neuron, that is before autonomic ganglia, and the second set of neuron we call as postganglionic neurons. In the figure it is only one neuron, but it may be more than one. And this set of neurons, since it originates from the craniosacral area, we call it as parasympathetic neurons or parasympathetic nervous system. And in the synapse, for conducting the impulses across the synapse, there should be a chemical mediator. And the chemical mediator, what we call is neurotransmitter. And the neurotransmitter in the autonomic ganglia is acetylcholine. And the effector junction for parasympathetic neuron, it is again acetylcholine. Being acetylcholine, the neurotransmitter in the autonomic ganglia as well as the effector junction of the parasympathetic nervous system, we call the parasympathetic nervous system cholinergic nervous system or cholinergic neurons. That makes some difference from the physiology. Pharmacologically, we call cholinergic nervous system because acetylcholine is the neurotransmitter in the autonomic ganglia, that is the first synapse, and acetylcholine is again the neurotransmitter in the effector junction, that is the second synapse, the effector organ. And if the neurons are originating from thoracolumbar area, definitely we call them as sympathetic neuron. So you can see the anatomical difference. The first neuron is shorter, the second neuron is more lengthier. And the second neuron will form the synapse with the effector organ like the cholinergic neurons, and the synapse between the first and second neuron is known as autonomic ganglia, and synapse between the second set of neuron and the effector organ is known as effector junction. And first neuron again it's a preganglionic neuron, and the second neuron again it's postganglionic neuron. And since it originates from the thoracolumbar area, we call it as sympathetic neuron. And coming to the neurotransmitter, again in the autonomic ganglia it is acetylcholine. But in the effector junction, it's not acetylcholine, it is noradrenaline. Since it is noradrenaline in the effector junction, these neurons are also known as adrenergic nervous system or adrenergic neurons. Why they are known as adrenergic? Because the neurotransmitter in the effector junction, you can see here, effector junction it is noradrenaline, but in parasympathetic it is again acetylcholine. So that is the reason why we call parasympathetic neuron as cholinergic neurons and sympathetic neuron as adrenergic neurons or adrenergic nervous system. Neurohumoral transmission. How the impulses are conducted across these neurons, that is across the preganglionic neuron and across the synapse, that is autonomic ganglia, again through the postganglionic neuron and again through the effector junction, finally it reaches the effector organ. So the messages across the synapse or neuroeffector junctions by the release of humoral chemicals, what we call neurohumoral transmission. The steps involved are, one is impulse conduction, that is conduction of impulses through the neurons. Second is the release of transmitter, that is neurotransmitter release in the synapse. Third is postsynaptic activity. So there are two synapses. One it is autonomic ganglia and one it is effector junction. So what is happening after the synapse, that is what is happening after the first synapse, that is autonomic ganglia, and what is happening after the second synapse, that is the effector junction. And third one is termination of action of neurotransmitter. So every neurons, the neurotransmitters are leaking every second in small amount, but it is not able to produce any action because it is rapidly removed. But whenever there is an impulse or a stimulation, there will be a massive release of neurotransmitter into the synapse, which will be eliciting or producing an action. So once it produces an action, the neurotransmitter has to be removed from the synapse so that the second impulse or second informations can produce an action again. So the neurotransmitter should be removed from the synapse once the action is produced. That is termination of action of neurotransmitters.